Hi everyone, in this video we're going to learn about how to translate sine and cosine. So remember from geometry, translations meant that we're shifting a graph left or right or up or down. We did some of this when we did all of our graphing back in chapter 2. Remember if our vertex of like the parabola moved, it could move our graph left, right, up and down. So same idea with sine and cosine, but in these graphs we're also going to have the stretches that we did last class that the period and amplitude cause. So our idea here is pretty much the same as what we did from 4.1. We're going to do the same kind of steps, but since our graph shifts, our first value is not going to be 0 for our x numbers, it's whatever our shift is. And then our y numbers are going to be affected by our vertical shift. So instead of just multiplying by our a number, we're going to have to add or subtract in whatever our vertical shift is. So now we have like our complete equation where c represents our vertical shift. A is still the amplitude, so that's our vertical stretch. B is what helps us find the period. And that's our horizontal stretch. And then D is our, sometimes it's called the phase shift, but it's our horizontal shift. And it has to be the opposite of the sine, just like in vertex form of a parabola, it was always opposite of the sine. So let's take a look at our first example and see if we can figure this out. Okay, so I set up a table for us to use. We're going to use our 5 values. So let's list out everything that we have over here and see what we have. Okay, so our amplitude is 3. That means it's going to be our vertical stretch. Our period, or our B is 2, which helps us find our period. It's our horizontal stretch. Our C is that number out in front, up here, and that's our vertical shift, so it's going to move our graph up 2. D is our horizontal shift. Remember, it's opposite of the sine, so pi over 2. So that means we're going to move our graph to the right, pi over 2. And like I said on the front with the steps, it says that that's going to be your first x number, because that's where our graph is starting. We're moving our starting point from 0 to pi over 2, so our initial value is your D. Okay, so to find our period, we did just like we did before, 2 pi over b. So our period is pi, and then to find our interval, we divide that by 4. So we get pi over 4. So now we need to find the rest of our x numbers. So we do that by adding our interval. Since I don't have common denominators, I'm going to change this to be a 4, so that way I can just add my common denominators. So to get this to be a 4, I multiply the top and the bottom by 2. So that would be like 2 pi over 4. So I'm now adding 1/4 to 2/4. So our next would be 3/4. After that we'd have 4/4, which is pi. Add another one, we would have 5/4. And another one we'd have 6/4. So usually what I do is I write the simplified version in my table, but I write the other ones above it so I can like remember my counting, the pattern. Okay, so now we need to find our y value. So remember, we're doing 2 things to the y. We're stretching it out by 3 and we're shifting it up 2. So first, remember what your key values were for sine. And our first thing we're going to do is do that stretch. Always multiplication before addition. So times everything by 3. If you think about it, here we'd do this 3 times whatever this is, and then we would add 2 to that. So now we're going to add 2. And those are our final y values. So to figure out your y values, first find what your key values are, apply the amplitude, and apply the vertical shift. Okay, so now that we have all of our points, we can make our graph. So like I said in class, I want us to use graph paper for all of our graphs. So I already pre-made my graph with my intervals that I have. So remember, each box will be what your interval is. So I have 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, and then we can plot our points from there. So our first point is at 2/4, and we're at 2. At 3/4, we're at 5. Back to 2, -1, and back to 2. And there is our sine graph. Remember, your graph should be a curve, so it should be shaped like rounded, and then you need to make your arrows at the end go in the right direction. Okay, very good. So as far as your notes, what I'm going to do is I'm going to just put a little piece of tape here so that way you can flip up and we can still see everything underneath. Okay, so let's look at our second one and see what we got going on with this one. Okay, so I didn't put to list everything. If you want to do that, if listing it all just like this helps you, then please do it. But from right now, I'm just going to find the period and the interval, and you can list out what each thing does to your graph and list out all your letters. Remember, it's going to be C, A, B, and D. So our first thing we need to do is find our period. So remember, that's 2 pi over B. So period's 2 pi over 3. And then to find our interval, we divide that by 4, which remember we talked about is the same thing as multiplying by 1/4, which I would do if you already have a fraction for your period, because it makes it simpler. So we would get 2 pi over 12, which can be reduced to pi over 6. So we're going to jump pi over 6 each time. Okay, so now what we'll do first to make our table is our first x value is our shift, and remember it's the opposite of the sign, so that means we're going backwards, negative pi over 4. So since my interval is in sixths and I have fourths here, the common denominator would be 12ths. So I'm actually going to add that 2 pi over 12 to get to the next one, but I need to make this 12ths. So to get a 12 done here, I would multiply by 3. So that'd be negative 3 pi over 12ths. So when I add 2 to negative 3, I would get negative pi over 12. I add 2 to negative 1, I get pi over 12. That's a pi. Add 2 more, I get 3 pi over 12, which is like pi over 4. And add 2 more, I get 5 pi over 12. So from here to here should be our period. And if we subtracted that, we would see that it's 2 pi over 3. I'm just going to show you real quick. 5 over 12 minus negative pi 1/4. And we would get 2/3. So that's our period from start to finish. We're still going to have that 2 pi over 3, even though it might be hard to see with all those crazy 12ths and 4ths and stuff. Okay, so now we need to figure out our y values. So our normal cosine is 1, 0, negative 1, 0, 1. Apply your amplitude first. And then your phase shift. So our phase shift, or vertical shift is negative 3, so that means we're moving our graph down 3. So subtract 3 from each of those numbers. So we'd have 1, negative 3, negative 7, negative 3, 1. Okay, so again, I made my table going with each box being worth a 12th. So 1 12, 2 12s, 3 12s, and then the same thing this way, except positive. We're going to need left and right since we moved our graph backwards. Okay, so our first value is at negative 3 pi over 12. We're at 1. And negative pi over 12, we're at negative 3. 4, 5, 6, 7. Okay, so we got our points. Now we just need to sketch what our curve would look like. And there we go. Okay, so remember to write down any questions you had if you didn't understand what we did there. Okay, so let's take a look at one thing in our next one, and then I want you guys to do the rest of it by yourself. This graph, or this equation, is a little bit different than our other two. What's different about it? Good. They put our b right inside our cosine instead of outside. Our x has to be plane because it doesn't tell us our true shift if it's not, and then we'll mess everything up if we don't get it where this x doesn't have a coefficient. So we need to factor out that GCF. It's not really a GCF. We just need to get rid of this 1/2 and put it on the outside. So we can take it out. It's like dividing out the GCF. So it's a 1/2 that's in front of the x, so we're moving that out. So we need to figure out what we would have here if we moved out that 1/2. So remember, it's like when you distribute, we get pi. So what would we have to times by 1/2 to get pi? Good, it'd be 2 pi. It's also like dividing. So if we do pi divided by 1/2, you flip and multiply. So if we divide by 1/2, we get 2. Okay, good. So I want you to try to finish that on your own, and then when you come back, I will show you what we got for the answer. So go ahead and pause your video to finish that last example. Okay, so let's take a look. So here's our table. We shifted back -2 pi. Our interval ended up being pi, so it was pretty awesome. We just counted by 1. And then we have an amplitude of -1, which flips it upside down. A negative flips, so instead of starting up, it's going to start down and then go up and back down. And then we added our 3 to shift up. So on this one, I know I said I make my interval each box, but I wanted it to stretch out a little bit since that's what the period is doing to it. So I made every other box, or I made each box worth pi/2. So that way my graph wouldn't be all condensed and smushed together. So here is our first interval, and then I graphed another one. So I have 2 periods on this graph. I just wanted to show you what happens if you keep going. So sometimes you'll be asked to graph over 2 periods, and that's what it means. So once you have your first stop finished, just continue the pattern. So go up, up, down, down, and then you would have the second interval. Okay, very good. So make sure you write down any questions you have so that we can ask or talk about them in class tomorrow. And we will practice how to do this and 4.1.